Okay, we're just going to introduce you to polar coordinates in this video. So basically, what are polar coordinates? Well, they're just another form of identifying points in the XY plane. Now, polar coordinates are helpful when working with complicated functions or equations. So to define polar coordinates, we first fix an origin, or called the pole, an initial ray from the origin. So right here, if you look down here, this is the origin we'll call O. And then notice I have the x-axis here. So this is kind of like the x-axis. So basically, if I want to identify a point in the plane, so let's say I want to identify that point right there, well, actually all I need is to know how far that point is from the origin. So we call that the radius. And then I have to know, if you drew a line from the origin to the point, what angle would that line be from the x-axis? And that's theta. Okay, so we're going to call that angle theta. So really, if I know the distance r and the angle theta, then I can identify that point. And actually, these coordinates here, r and theta, are related to x and y in the following way. You can use trigonometry and show that the corresponding x, y value, so r theta would obviously have a corresponding x and y value in the Cartesian coordinate system, and you can easily show using trigonometry that x would equal r times the cosine of theta, and y would equal r times the sine of theta. Now, if you haven't taken trig, these might be new to you, but basically most calculators have trig functions. The trick is you have to make sure that if you're using angles, that your trig function is using degrees, and if you're using radians, the trig functions are using radians. And then also, it turns out that if you want r, well, just a simple Pythagorean theorem, if the distance, this point is y units from the x-axis, and then that point is x units on the x-axis, so you know that from the Pythagorean theorem that r must equal, r squared has to equal x squared plus y squared from the Pythagorean theorem. So that's the relationship between x, y, and r squared. So before we get started, let's convert a Cartesian coordinate to polar coordinates, and let me show you how that works. So let's say x is 5 and y is 5. Okay? So, well, based on this formula, we know that r squared has to equal x squared plus y squared. So r squared must equal 5 squared plus 5 squared, which is 50. So since r squared is 50, r must be the square root of 50, which can be written as 5 square root of 2. Now, since we know x equals r cosine theta, then we can put in 5 for x, and r we know is 5 square root of 2, and cosine theta we don't know. But if we divide 5 square root of 2 into 5, we get 1 over square root of 2. So the cosine theta is 1 over square root of 2, or you could say square root of 2 over 2. Now, this is actually a common angle. So if you took trigonometry, you would know that 45 degrees, or pi over 4 in radians, is theta. So cosine of 45 degrees, or cosine of pi over 4, is always equal to square root of 2 over 2. So basically, this point in Cartesian coordinates would be r is 5 square root of 2, and theta is 45 degrees, or you could just write it, normally it's written in radians, 5 square root of 2 and pi over 4. Now, if you don't know how to do this, you could actually use the inverse trig function and theta, or the arc cosine function, so on your calculator, and you could figure out that you might have to go to YouTube to figure this out, but you could find the arc cosine of square root of 2 over 2, and it would give you, if your calculator's in radians, it would actually give you a decimal number, which is pi over 4. But if your calculator's in degrees, in the degree mode, then you would get 45 degrees for this arc cosine. So anyway, you might need to do a little research on that. Okay, here's another set, the 0.34. Well, in this case, r squared would be 3 squared plus 4 squared, which is 25. So r would just be the square root of that, which is 5. And then x would be, since x is our cosine theta, then we know x is 3 and we know r is 5. So we could solve for cosine theta and get cosine theta is 3/5. Okay, well this gets a little tricky. So now we're going to go to the calculator and I'm going to actually apply that arc cosine function to 3/5, which is 0.6. So that's going to be 0.6, and in degrees that's going to be 53.1 degrees. So you could write your r as 5 in both cases, and in radians it would be whatever the arc cosine of 0.6 is, but in degrees it would be 53.1 degrees for theta. So now if you wanted to convert from polar coordinates to, let's say you wanted to convert from polar coordinates to Cartesian coordinates, then basically what we could do, I can't find my cursor here, where are you? There we go. Alright, so let's say r is 5 and theta is pi over 6. Well, this is actually pretty easy. You just grab a calculator, and remember x is r cosine theta, so x would be 5 times cosine of pi over 6, which is 5 times square root of 3 over 2. Now, cosine of pi over 6 is a standard angle, so any trig book will tell you that cosine of pi over 6 is square root of 3 over 2. And then y would be 5 sine of pi over 6, which would be 5 times 1/2. And again, any trig book will tell you that sine of pi over 6 is 1/2. So basically the x value would be 5 times square root of 3 over 2, and the y value would be 5 times 1/2. So that would be the corresponding point in Cartesian coordinates. And if you didn't know these cosine and sine of pi over 6, then obviously you could use a calculator and get the values. But the problem with a calculator sometimes, it just gives you a decimal. It doesn't actually give you the exact values of square root of 3 over 2. So, and that's what a lot of professors prefer, is the exact values. You'd be okay with 1/2 because you'd know if it gave you 0.5, then you'd know that's the same as 1/2. But square root of 3 over 2, you might not recognize its decimal form. Okay, so for more details, you can study this in trig and pre-calculus. Now, while I've got some time on this video, let me let you know that there's actually more to this. This is, like I said, just an intro to this, but there's actually equations that can be written like r equal theta describes a particular graph, or r equal sine theta describes a particular graph. Okay, and actually these formulas, or maybe r squared equals sine theta, but actually these can be converted. These formulas can be converted to formulas involving x and y. Sometimes it's difficult, sometimes it's not so difficult, but basically if you graph, you can actually get graphs of these, you know, on using the r and theta coordinate system. You can get graphs of these, and some of them are pretty cute. You might get a spiral that does something like this. Okay, or you might actually get something that looks like a flower that does something like that, and so forth. But anyway, they're interesting. It's an interesting way to graph graphs that are difficult to graph using x and y, but are more easily graphed using polar coordinates r and theta. Okay, that pretty much ends the chapter on conic sections and polar coordinates. So we'll move on to another chapter in the next video.